What are abalone? Let me ask you that, the little audience participation here. What is an abalone?
Yeah.
Exactly. Or it's a mollusk also. I'm going to be talking tonight a little bit about this particular animal. This is the shell of a white abalone. I started Proteus Sea Farms a long time ago, about 20 years ago. Also, more recently, I helped found a nonprofit organization here called the Channel Islands Marine Resource Institute. And it's pretty much through the Resources Institute I'm going to be speaking tonight. This is work that's sponsored. A lot of it is federally funded through grants and the like. There's also local sponsoring for this particular program. So let's just jump right in. There's three aspects of it, and Gary's right. I kind of have a foot in both worlds, both in the farming and the commercial aspect of raising marine animals, but also very much in the research world as well. And it works well for me. You need both. You need to do the science to find out how you improve your methodology. For the White Abalone Recovery Program, there's kind of three phases of what we do. We have research, enhancement, and education. This is a white abalone. They're not white, by the way, at least not the shell. The foot is white, and the inside of the shell, the maker, is very white also. This particular animal is a farm-raised animal, and you can see it's very reddish in color. Their shells change color based upon what you feed them. This particular animal has been eating diatoms, things like that, so the shell gets very red. If we feed them red algae, and I'll talk about that, the shell will also turn red. So the white abalone is a Southern California species found from Point Conception to Baja. It's a deeper living animal, and it feeds, it's a drift algae feeder. So basically, when they're very small like this, they'll raise diatoms, or on algae. As they get larger, they catch pieces of drift kelp that come by. Here you can see the distribution of the different abalone species in the West Coast. And this is actually an old slide, and you can tell that because there's 8 species here, and we really only have 7. 2 of the species, the pinto abalone and the threaded abalone, a system has figured out that those are really the same species, but the shell changes over time. Not over time, over geographic location. The white abalone, as I say, Point Conception, all the way down to Baja, and we also have other species here, some of you probably know firsthand. We have greens and blacks and reds and pinks as well. These are some of the species. Now, one of them says important for fisheries. Well, gee, guess what? Red abalone, yes, we're very important for fisheries. Black abalone, we're important for fisheries. Green abalone, pink abalone, white abalone. We're all fished. Pinto abalone fished more to the northern part of the Washington state. Threaded abalone and flat abalone, which are smaller abalone. Again, the thread is the same as the pinto. Threaded wasn't fished very much with the flats, but by virtue of their small size, they weren't fished very much either. White abalone occur here in Southern California, pretty much in the California, the warmer water section. So we will find them a little bit on Santa Cruz Island, certainly Anacapa in the areas of here where white abalone habitat, but also on the coast here as well, north of Santa Barbara. It's one of the few places where we actually do find them, or did find them on the coast. I want to thank Gary Davis for the next couple slides. And this was the look at the fishery. You know, what was the California commercial fishery? Now, this didn't count sport landings. This is commercial landings. And if you look at this, you say, man, they weren't doing too bad here. It came a little worse here, and something really bad happened there. And what you find is that there were actually a bunch of fisheries stacked on top of each other. And what you got was serial depletion. So here you have the red abalone fishery and the white abalone fishery. They both kind of petered out at the same time. But gee, guess what? Then people came in and started fishing black abalone, started fishing green abalone, and this little blip down here, that was the white abalone fishery. It didn't last very long. Now, one thing that you can also say about this is, well, okay, so we only have this little white abalone fishery. It only lasted maybe 10 years. But one thing you have to keep in mind is that all these pink landings probably included white abalone, because Fish and Game in their commercial book didn't have a special checkbox for white abalone back during that time period. So those pink abalone landings probably included some white abalone as well. So the fishery was probably longer than just that little 10 years. A little brief timeline of white abalone. So it looked like the last major recruitment. That's when the abalone spawn, the larvae settle, and they grow out and they reach a size of, say, 1/2 inch or an inch. That's considered a recruitment. probably happened in the 1960s. You say, well, how do they know that? Well, when they did some surveys looking at the shells that they found, they were finding all big shells. This is back in the 90s now. They were finding big old shells down there, and figuring about how old they were, they said, well, probably it happened then. Again, the fishery was a very short period of time. Now in the late 90s, California Department of Fish and Game closed all fisheries in Southern California. So if you're fishing abalone, or if you know anybody that's taking abalone in Southern California, tell them, please stop. A, it's illegal. B, it's really hard on the animals because there's so few left, and if you take those few, we're not going to have any at all. The National Marine Fisheries Service also looked at some of the literature. They went out and worked with the Channel Islands National Park, the Sanctuary, National Marine Fisheries Service, and looked at how, what is the status of the white abalone. Based upon their work, they said, well, gee, this thing should be listed as endangered. There's so few of them left now in their existing range. So Fish and Game actually went and collected some abalone for us in 2000. And we did our first large-scale spawn in 2001, and not just our first large-scale spawn, but the first large spawn of white abalone ever. And then that same year, they were listed as our first marine invertebrate as an endangered species. Our programmatic approach is to first survey the known habitat and look for remnant populations. And again, that's what the National Park Service was involved with, Fish and Game, and the National Marine Fisheries Service. Bring some of those adults in, and then cultivate them in the hatchery. It's the same strategy that's taken, say, for the Condor program. Round up the survivors, bring them in, propagate them, and eventually let's get them back out in the wild. So for these first steps here, this is one way to find white abalone. Again, they're a deeper living abalone. This is an ROV, belongs to the Department of Fish and Game, and this is on a sanctuary boat in Shearwater, and we're looking for white abalone. Since they are so deep, it's really difficult to send divers down at 150 feet and do very much searching, because all of a sudden they're maxed out. They have to come up, they have to decompress for long periods of time. It's an inefficient use of manpower. With the ROV, you can go down easily to 150 feet or deeper and stay down there for quite a while. We also use old divers like this. And we send them, actually the old divers telling the young divers to go down and get stuff. But they go down, once we find an abalone with the ROV, the divers jump in, and they can follow the umbilical cord for the ROV right to the spot. Now this ROV was zoomed in on an abalone that was right here, parked right in front of it. It looks further away, but that ROV was probably only 3 or 4 feet away from the actual animal. The divers then come down. We can actually kind of see how good a job they're doing when they get the abalone, but then they can bring it right back. They minimize their bottom time, and they don't have to decompress because it's a real quick in and out. There are a couple of animals that we recovered during that particular dive. Once we get them into the hatchery, here's another one. We feed them a couple diets. We have giant kelp, Macrocystis over here, and a red algae, gulls. You can see a nice red shell, not a white shell, very red shell. This tells us they're eating a lot of red algae and things like that. To spawn them, we use a couple of methodologies. This is a methodology where essentially we induce spawning of ripe animals by using UV irradiated seawater. This is a technique originally developed in Japan. A similar acting technique was developed at UC Santa Barbara, where they put low levels of hydrogen peroxide in the water. The animals spawn in those individual buckets. There are separate males and females. The sexes are separate. They're not like oysters where they can change sexes. Once you're a male, you're always a male abalone or female. We raise the larvae in vats like this, or we can raise them in buckets. If we have small batches, we can raise them in these 10-liter buckets like this. Or if we have larger batches, we can raise millions of larvae in each one of these vats. The larvae are swimming around in here. This is a large filter that prevents them from going down the drain. You can see some of the larvae sitting on the bottom here. The larvae are 1/4 of a millimeter in diameter, and they only stay in the larval stage for about 5 or 6 days. It's temperature dependent, but it's a very short larval period. The very nice thing for the abalone farmer or the cultivator is we don't have to feed them. Excuse me. They absorb amino acids through their skin, but they don't have a working digestive tract when they're larvae. So we'll keep them in these vats for about 5 days. When they're ready to go, when they're developed, they haven't gotten any larger. They're still 1/4 of a millimeter. But we settle them in these tanks in our hatchery. In these tanks, we grow microalgae. It's just like that. Who's been on the beach and slipped on the rocks and fallen down on their bum and said something nasty? Yeah, we raise that same kind of algae. And that algae is on those rocks in the intertidal because of several reasons. You've got water, seawater, you've got sunlight, but you have these small grazers that you don't really see an awful lot of the time. But small crabs that come out, a lot of limpets that come out, that keep that algae grazed down. That constant grazing pressure produces a specific microalgae community, and it's composed of, there's also bacteria, but there's microalgae, there's diatoms, there's monostromatic or very rock-hugging algae, and that type of algae community is ideal for juvenile abalone. So that's exactly what we raised, and you can see we've got racks of algae. And these are plastic racks. As a matter of fact, this is very exotic material. It's the same stuff you used to see on roofs. It's that fiberglass roofing material. It works quite well. It's very cheap. And we get a large surface area, because that's what we need. Abalone, at this stage, you're dependent upon surface area. The more you have, the more abalone you can raise in a particular tank. So we grow the algae on there, and you can see the abalone on there as well. There's another shot of the abalone sitting on the racks. All these little white dots, it's a small polychaete, and if any of you have boats, you probably swear at those little things because they instantly grow on hard surfaces underwater, and they'll foul the bottom of your boat. But this is the first production. Now this stage up to here takes anywhere from 6 months to a year. Again, it's a little bit water temperature dependent. It's also density dependent, which we'll get into a little bit. If there's more of them, they grow a little bit less. There's less resources. As they grow on the place, you can see that they are very, very good at camouflage. This is a coralline algae, which is naturally grown on our plates also. And you can see how well they blend into that coralline algae. They also graze on that coralline algae. It provides some nutrition. It's not the best, but it gives them some. Again, you can see how hard it would be if you were swimming along with a mask on and trying to look at rocks to see those little abalone. Now, even at this tender age of about 6 months or so and 10 millimeters in diameter, they have a radula. It's kind of like a belt sander tongue, if you will. Belt sander tongue that has little teeth that flip out as it moves it. So it rafts away at the algae, and that little radula is quite tough because these guys are making all these holes in this blade of giant kelp. We can also see here, and I don't know if any of you tried to pull, the Kelp Stipe, but it's quite tough, and yet they're chewing holes in it very, very well. This is Featherbow Kelp. It's a intertidal or high subtidal kelp you'll find out here around the harbors. Extremely tough. It's almost like a leather belt, and yet they can easily graze the surface of that right off. We raise dulse, red algae. It's Palmeria Mullis. Any of you seen it in a health food store? Dulse? They sell dulse flakes. It's harvested wild mostly, but we grow it here for the abalone, and we'll get into a little bit here. You can see they're eating that, and there are some animals that we produce. Now, the second part of the program is looking at applied research. So we've done the first thing. We've been able to round up enough animals so we can bring them into the hatchery and spawn them, borrowing from techniques that we've used for red, green, pink abalone, Japanese abalone, other parts of the world. Modify those techniques so we can grow white abalone on a pretty large scale in a pretty small facility. So the next thing is, interestingly enough, this particular abalone has been, well, okay, let me back up a little bit. Abalone species overall have been in California. Give me a guess, anybody. How long? Forever. That's a pretty good guess. Anybody else have another spot on that?
30 million years.
30 million years, that's a good guess, okay, but I'm not going to let this abalone go for any less than 100 million years. 100 million years in California. There are abalone fossils, and they look very, very similar to this. They have not changed their shell shapes very much in that amount of time. It's quite striking. One of the things that, although it's been around for a long time, this particular species, white abalone, was not even identified as a separate species until 1940, which is just kind of yesterday in terms of our experience here in California. Even though we fished these guys for a very long time and people ate them with great gusto. We know almost nothing about their biology. Most of the biology consisted of very few studies. One was a PhD thesis that was done in the 1970s. And beyond that, very, very little information, little anecdotal information, if you will. So we had to kind of start from scratch on what makes these particular animals unique, what are the types of requirements that they have, what do they like to eat. So we're doing applied research, and that will eventually, we hope, lead us to being able to produce abalone on a regular enough basis so that we'll be able to supply juvenile hatchery-reared animals for outplanting. And of course, to do all this, you need a large group of people with different expertise so that you can come together and help each other out. I'm going to cover just a little bit of the research that we're doing, so give you a little glimpse of what we're doing. These are some of the questions when there's the National Marine Fisheries Service, once they declare this thing as an endangered species, they have a program where they have to go in and say, well, okay, how are we going to recover the species? And they have a long list of questions, you know. And some of the questions are just like this, like, well, what's the optimal temperature? What does it eat? We don't know. What's the optimal density for this species? We don't know. There was a lot of big circles on our list, so we started in looking and trying to answer some of those. So I'm going to talk a little about these a little bit. Feed. We've done some feed experiments, and you can see this is over the course of 144 days, and we fed small, juvenile, white abalone, a wide variety of diets. And you can see the basic takeaway here. We're not going to read each diet, but you know, some diets, here we're at 15 degrees centigrade, I'm feeding them chondrocanthus, which is it's a red algae that often washes up on the beach. It's the common name is cow's tongue. It's got a warty kind of thing. It looks like a big ugly cow's tongue. They don't do very well with that at all. That's not a very good nutrition for them. On the other hand, if we raise them at 15 degrees centigrade and we feed them giant kelp, that does pretty good. As a matter of fact, they do pretty good on dulse at 15 degrees also. And if we feed in laminaria, which is another big red, another big brown algae, plus dulse, they do pretty well also. So we said, well, okay, so for our purposes, we can get macrocystis very easily. We can grow the dulse, so this will be our diet that we'll feed them. We also looked at densities. And how many abalone can you put in a tank? You know, I know if I put one abalone in a tank that's this big, I'll have one very big, very happy abalone. And if I put 10,000 in that tank, well, I might not have so many happy abalone, and maybe they won't grow so fast. And so the question is, well, let's start someplace. And so these starting points are, this is the level that you raise Japanese abalone at. It's a very, this is how many grams of weight per liter of tank volume. This is for what the level that red abalone raised on a commercial basis, so we started there. And guess what? If we raise them at the high densities, they don't grow as well as the lower densities. So this at least lets us quantify what we have to be searching for in our hatchery. You know, what level should we be raising them at? Next is age of reproduction. Again, I said we know very, very little about white abalone, and some of the things that we do know are kind of, we make extrapolations from other species, from red abalone, from green abalone, from pink abalone. And so it was kind of thought that the white abalone matured maybe after 4 to 6 years, and at a size of maybe 90 to 125 millimeters. Now, it's important to know the age of reproduction, because if you're going to put little abalone out to recover stock, you want to know, well, how soon they're going to start reproducing, or how soon they'll be capable of reproducing, because you know, once they're put out there, everything in the world wants to eat them, so you want to make sure there's enough to reproduce. One of the things that we found in the hatchery is that at a very tiny age, these things are only 1 inch. This is a male, this is the testes here, and this is a female. Our experience with red, green, and pink abalone said, well, this is really unprecedented. None of those are ripe at this young age. And so we now know that white abalone are significantly different from these other species, and that they can reproduce at a very, very small size. Now, we also looked at behavior, because behavior is important. Will these abalone sense food? Will they sense predators? You know, is there a chemical signature that they'll pick up? And how do they move around also? So what we have here is a little behavioral experiment, and I don't know if anybody work with rats in college, you know, anything like that, but this is nice. They don't really have personalities, the rats, I guess, but they do have personalities. What we're doing here is we have these little test rooms, and we have 2 sources of water for each little raceway here, each little replicate. One source of water is a header tank that's sitting over there, and the other is a header tank sitting over here. So everything is identical down to this point. We have a little abalone sitting in a cage here, and with a rock on top, so they won't push it away, and we acclimate them to that. Then what we do, here's a little close-up of it, so they won't go anywhere while it's being acclimated. Then we take the cages off, and we might put something in each one of the header tanks. For instance, put a lobster up here and put nothing up here, or put a food item up here and put nothing up there, and to see, will they make a decision? Will they make a choice? Now, the problem, the difference, say, between rats and abalone, we're dealing with snails here, somebody pointed out. They're slow. It takes them a while to figure out where they want to go. We need to do more work on this, because here, this animal has clearly made a choice. I want to be up this one. I want to be away from this particular area. This one's decided that maybe he'll run away, so the little tentacles on his head, the cephalic tentacles. He said, well, maybe I'll run away from the whole thing. These two haven't made up their mind. Neither has that one. But we're learning a little bit about what makes these tick. Here we have a group from Oxnard College. That's Dr. Buckley, Lori Buckley, and a bunch of students. We're doing a little bit more extreme experiment here, and we wanted to find out what happens. How do they react when you put a major predator? This is a sea star, sun star. These are, as one national park biologist points out, the white sharks of the invertebrate world. They will move very fast. They will eat anything, and abalone is certainly high on their list of desirables. So, and what we're learning is we're finding out that abalone actually do have sort of an escape response, and it's not only physical, but it can be chemical as well. So we're starting to do some work with UCLA on exactly how that works, what that is. Now, we also are looking at behavior of hatchery-rated animals. So one thing we notice is they do this kind of peculiar thing. They reach way, way out looking for maybe food or maybe something else. And it struck us that maybe they're looking for something else. Abalone have a feeding stance, and if I can put it up on the computer here for a second, the abalone will normally sit on, say, a rocky, hard substrate like this. When they're feeding, they'll kind of tilt the front of their shell up, and the foot will kind of extend out here, kind of waving around, waiting for a piece of drift kelp to come by. What struck us about white abalone, which is very different, is they weren't doing just that. They were doing this. They were doing a full stand, a big high five, and initially we thought they were just hungry. And then we thought, well, maybe they're not just hungry, because we put more food in the tank, and they're still doing this. They're still waving around. So we thought, well, what if they're hitchhiking? Sticking their big foot out. They don't have a thumb. So what we did is we set up a test flume, and this is actually our new flume. And we put little abalone in here. We put about 100 abalone in here, and then we took some things that would be around in the abalone's environment, drift kelp, and we took the giant kelp, we took some Featherbow Kelp, we took some sargassum, which is a very fine frilly algae that they don't normally eat, and then as a control, we actually even took a piece of a bicycle tire. The inner tube of a bicycle tire, as a matter of fact, because when you cut it and flatten it out, it kind of looks like a kelp frond. So physically, it's the same thing, same size. And what we found, and this is kind of the behavior we saw, when there's a food item, especially macrocystis around, these guys will rear up, and they'll rear way up, and they will get ready, and they will jump on, here's another one, jump onto the kelp. We're up, and there we are. And we said, well, they're just trying to get something to eat. We said, well, yeah, but when we put our little kelp items down these raceways with all the abalone there, and of course we do this at night also, because abalone are nocturnal, they feed at night. And so we have just a little red bulb we found that over the course of a very short amount of time, it only takes about 20 to 30 seconds for, say, a piece of food to transit this long flume, we found that we would get about 6% of the population would jump onto that kelp blade and take off. Now, this has never been reported for abalone before, and we really scratched our heads. And we looked around in the scientific literature, and we found, lo and behold, there's a whole lot of other species that do this. There's lots of crabs, and there's lots of small amphipods, crustaceans, things like that, even some other mollusks, even types of sea urchins that will do this. They'll get on a piece of drift kelp, and they take off. And then they go long distances. And they go, some sea urchins go all around the Antarctic continent. So we found basically that before the thought that the only way that abalone get from one place to another place, say how do they get to Santa Cruz Island, how do they go from Santa Cruz Island, say, to the mainland, or from the mainland out to Santa Cruz Island, or to Anacapa, or some of these other islands, Clemente, things like that. Well, obviously, there's the larval plankton stage. Well, as I said earlier, the larval plankton stage only lasts 5 days. That's really not enough time, especially when you do a lot of drift card studies and things like that. It's not enough time to go from point A to point B. If, on the other hand, you can jump onto a piece of kelp and you're a juvenile, you can stay in that kelp a very, very long time. And I say that this long time, you can increase it, and your probability of survival and for successful reproduction is actually better because now you're protected by the kelp. So you can have abalone that are, say, out here on San Clemente Island, easily catching currents and maybe moving around Catalina, or they could move south all the way down into Mexico. If you were here on the islands, these currents actually come in a good part of the year. You can easily go transit from here to here, or you might even be able to transit from the mainland back out here in the gyre. So this is actually kind of exciting news. Now, you don't have to go by yourself. You could take a friend. And here, for instance, you've got 2 abalone. Oops, I'm going to go back. So you've got 2 abalone. One goes up on the kelp, and the other one goes with it. So they just go right back up. Now, remember that these little 1-inch abalone, they're showing this sort of behavior. They're already fully reproductively competent. So you could get 2 or 3 on a kelp plant, and they could land someplace else. You've already got a starter population. We're also looking at reproductive biology. How many eggs do they produce? What sort of sperm density? What sort of sperm density do you need? So here we've got an abalone that's just been spawned, and there's, I think, probably eggs in this one and sperm in this particular bucket. We're looking about what about those reactions. And again, for an endangered species, you want to have sort of an idea. And these are some students from Oxnard College. Sort of an idea of if you have an abalone here, and there was another one, say, a meter away, male and female, if they spawn, is there sufficient sperm to fertilize those eggs? A meter away, probably there is. But what if the sperm density is lower? What if you're in the back of the room? What if you're out there in the middle of a harbor and this particular female spawns and you're out there? Is it going to be enough sperm to actually reach those eggs? Probably not. So, but the question is, how do you quantify that? And so what we're looking at here is taking different batches of eggs in these little sieves and using different sperm densities to try to quantify exactly how many sperm you need to optimize fertilization. This is a couple of PhD students from UCLA. They're looking at the egg-sperm interaction, looking at if you have an egg, what's the best situation for fertilization? Is it a calm water situation? Or is it a very fast water situation? And they've come up with some very, very clever methodologies where they actually put the egg in little centrifuges spinning around and the sperm sort of swim around that. Not only that, the sperm seem to be able to track the smell of the egg, the chemical signature of the egg. So they can track individual sperm, watch how they move through the water column, and you'll see kind of like random patterns. After a while, you see those sperm are definitely going in a specific direction. They're going towards that egg. There's a chemical emitted by the egg that attracts the sperm. So we're working with them. Pathology. In about the 1980s, we started to lose a lot of black abalone here in the Channel Islands, in other parts of Southern California too. And it didn't really become apparent until the black abalone populations on the islands were hit. It probably moved up from the south, but it was hard to tell because the mainland populations of abalone were picked pretty thin, and there weren't that many intertidal. But populations were good out here, and what we found is when this mysterious disease moved through, we lost about 99% of the abalone, of the black abalone. It was just devastating. We also found out that it does affect green, red, pink, and white abalone as well. Turns out it's a bacterium, and it's a rickettsia. It's a prokaryote, and a single-cell bacteria. And it turns out it's very virulent and attacks white abalone as well too. So we've had it in the hatchery, and what we've found, though, that antibiotics work very well as a treatment for it. So we work with people at the University of Washington, and we're also looking at the fact that this RLP seems to not like lower water temperatures. What the RLP does, it gets into the abalone's gut, it changes the structure of the gut. It actually makes the animal move around some of its tissue so that it ends up with less absorptive area. The net result is that abalone can still be eating and it will starve to death because there's not enough absorptive area left in the gut of that animal. So the bacterium, though, doesn't seem to do very well at lower temperatures. Temperatures less than 16 or 15 degrees centigrade, the bacteria slows down quite a lot. At that rate, the abalone looks like it can slough off enough intestinal gut cells so it can kind of keep ahead of the bacteria. When the temperatures rise here in late summer, when temperatures go up to 20 degrees centigrade or thereabouts, the bacteria thrives. The animal can't slough off gut cells fast enough, and we end up with a lot of starving and shrunken animals. Here you see a couple animals. This is a normal little white abalone here. This is one that's starting to be symptomatic for withering syndrome. It's starting to shrink in a little bit, the foot's a little bit smaller, and you're starting to see the shell, the mantle retract from the shell there a little bit. Once the animals are symptomatic, once you see them going, there's not a lot you can do for them, unfortunately. Another recent issue that we've come up with is there's a shell disease that seems to affect white abalone as well, and it looks like this brown deposit here on the shell. And other species of abalone have it in Southern California. It looks like white abalone, for some reason or other, are particularly susceptible to it. So we're working with a couple of groups on seeing how do we combat this particular attacker too. It looks like it's a type of a fungus. Now, the next stage, so that kind of concludes our hatchery production. So we're doing, as you see, we're doing white abalone production. We're doing a lot of research and to answer a lot of these questions. And every time it seems like we answer a question, we get about 3 more new ones. We answer one thing and other things pop up. For the field work, we're looking ahead at, okay, how do we get abalone back into the field? Because that's going to be the next step, taking some of these hatchery-reared animals, putting them back out in the environment. We have to pick some benthic study sites, and we have to pick areas that were known white abalone habitat before. We need a monitoring device, and that's these little baby abalone recruitment trackers, or BARTs. And from these, we can get some baseline data on what the benthic invertebrate community looks like there. These are a couple of BARTs that we deployed a couple of years ago. And the park, by the way, has a similar device they call an ARM, an artificial recruitment module. They're sort of similar to these, except for every 2 blocks we have here, this is 1 block for them. And theirs are stacked in a very regular area. Ours has been described as looking like one of theirs after a storm. It's all the pieces are jumbled around in there. Now, there's a purpose for that. By jumbling the pieces, you can make smaller spaces, and they're really good little spaces for juvenile invertebrates to hide. It's all encased in this kind of lobster trap kind of mechanism. This keeps out the big predators. And as a matter of fact, when we went out last spring to look at some of the bars and monitoring, we're going on a trip tomorrow, you would see these sun stars, big, trying to reach into the trap. Now, the bars are too small for the sun star to go in, but the trap is just full of small invertebrates, sea urchins, sea stars, brill stars, a whole variety of little animals that live in these traps. This is preferable habitat for juvenile abalone. They really like these small spaces. They really like, it's essentially a controlled rubble pile. The thing that it gives us, though, also is we have a known surface area. If you're going to do benthic surveys and you start looking at, well, let's turn over rocks, well, that's fine, but it's really hard to measure the surface area of those rocks because they're usually all irregular. Here we know exactly how much surface area we're surveying, so we can compare bars in one site with a bar in another site. This is a Channel Islands National Park diver, Dave Kushner, and he's going down. We have 4 cruises per year. We use the sanctuary vessel, the RV Shearwater. We're going out tomorrow. And he will go down and take his video camera and survey one of these bars while we have students from Oxnard College on board the RV Shearwater. We have big video displays. They can watch what he's doing, we can listen to what he's saying, and we can ask him questions. So it's very interactive. He brings the animals, some of the animals back from the north, and we survey them on board. This is, again, this dovetails with a program that the park already has, a kelp forest monitoring program, which has been going on for at least 2 decades, is that about right? 25 years, yes. So this dovetails with their existing program. We can check our barks to see how they, do they attract different things, say than the arms. This data also is useful for the park as well. There's on the Shearwater, one of our cruises. Some of our next steps is we need to produce new crops of abalone, and we need to get more broodstock abalone as well. We are down to, right now, 5 adult white abalone as our broodstock animals. We started with a relatively small pool. Our bigger chunk of that pool is about 9 animals. Abalone die after a while. They are old animals. They do die in captivity for a variety of reasons. And we need to go get some additional animals as well. We need to look at how we're going to outplant some of these hatchery animals. We've already established some study sites. And then once they're out there, we need to be monitoring growth and survival. This program, as we've been working on over the years, there's a lot of program partners that we work with. And the program, I couldn't do this myself, obviously, it's a huge undertaking. And so we work with a wide variety of people, just on the both production side, the science side, on the financial support side. We have a bunch of program supporters here also, people that help provide monies to the work that we're doing. And again, we couldn't do it. No one participant gives large amounts of money. A lot of participants give small amounts of money, or they give in-kind work. For instance, we get the RV Shearwater 4 days a year. That's a huge amount of contribution. The National Park Service contributes divers 4 days a year. Again, a very huge contribution. We couldn't do it by ourselves. And with that, I will entertain any questions that you might have. Yes?
Having such a brood, your broodstock being so few animals gives you plenty of critters for research. But if you were going to breed animals to restock, wouldn't you need more for genetic diversity?
Well, the genetic diversity that we get, we do pairwise weanings, and we manage by pedigree. So that is, we know who the mother and father of each particular animal are. So we can, even with 9 animals, you can make a lot of crosses that are unrelated. Then you can take some of the offspring of, say, pair A and B, take those offspring and mate them back with C and D, because they're unrelated. So there's actually quite a lot of crossing that we can do. Yes, we do need a bigger pool. I mean, ideally, we would have a pool of 50 to 100 animals. The problem, though, is it's very difficult to find that many abalone out there now. That's the first part. The second part, it's very expensive to go get those animals. If you're talking about ship time, like diver time, it's a huge undertaking. But again, we get lucky sometimes. We find some where we don't expect them, so we'll be getting more. Yes?
I heard that they were raising abalone off one of the oil rigs that is not in working.
A long time ago, maybe 20 years ago, they did have some abalone they were raising there. There was some talk about Hub's Research Institute coming up and using one of the rigs that wasn't being used. Then the price of oil went up, and I think they're thinking about putting the rig back into service. So I haven't heard them doing it recently. When they did it back 20 plus years ago, they made cages, put the abalone in the cages, and they found out what they were making were octopus hotels. Because the octopus moved in, and they thought they were in heaven. They were like abalone to eat every place. It was really difficult to get them out, or to service them. There have been some cages off of Santa Barbara where they were raising abalone below the surface to different degrees of success. I don't think there's any right now, but there have been. Next question?
Does the depth of the water from which you're obtaining your abalone make any difference in the breeding program?
Not really. We actually, our deepest tank is only about 2.5 feet deep. It doesn't seem to affect them whatsoever. The white abalone, probably, the ones we're finding now, are probably at depth for two reasons. One, the shallower ones have been fished out mostly. But two, there have been some studies that show that occasionally the green abalone, the pink abalone will kind of outcompete the whites and kind of push them out of a range. So there's kind of a little interspecific competition that goes on as well. But no, they do quite well in a couple feet of water for most of their lives. It doesn't seem to affect them. Yes?
Have you noticed, what are some of the results from the barks as far as, are you counting the individuals then when the divers go out and trying to assess sort of growth and
County
abundance,
individual,
or-
what? County individual what?
Abalone, that
well,
are in
okay.
the barks.
We have not put abalone out, our hatchery animals out where the barks are yet. So the abalone, and we did find an abalone last December, that was a wild abalone, that was a wild red. And yes, we count them, and we measure them. And all of the invertebrates in the bars, well, not all, but the subset of invertebrates in the bars that the National Park monitors in our arms, we measure those in the bars also. For instance, brittle stars, they're all over the place. Nobody measures them right now. So, but we do measure and keep track of those animals, yes. Yes.
What's your restoration goal?
Our restoration goal,
How many animals, will be out there when you consider it successful? How many animals will you have out there? Will you see how that?
I don't have any hair left by that time. That's a very good question and a very difficult one to answer. Initially, what we envision is starting in some sites and perhaps putting down 1,000 or 500 animals in a particular site and monitoring those with our existing BARTs over time. White abalone occurred in a wide range of California. We're talking about Point Conception all the way down to Appalachia Baja. To bring them back within that entire range is a huge undertaking, and I don't think it's possible, quite frankly. So what we would have to look at is certain areas where we think the best chances of success are and concentrate on those. And that may be only 2 or 3 sites to start that process. We're not even there yet, though. Again, this program, we've been working since about the mid-90s, so we're 10 years and actually a little bit more into it now, and we don't even have animals in the water yet. So it could easily be another 3 or 4 years before we get animals into the water. So it's a very long-range program. Yes.
So would part of that, looking at different sites, be looking at the currents and everything else, and then we're looking at that behavior of the hitchhiking, you might be able to then set a couple of source populations out there and based on...
Exactly. You might be able to do that. You might be able to pick an area that's got good tidal flow, that's got good kelp beds nearby, where you get a lot of drip kelp, and use that as your source area, and then see if the abalone will then pick up and take off. And of course, it's really hard to figure out where they're going to go because the tides change and the currents change with the season. We could, I suppose, we could tag some of those animals, and one approach we've had is you put those sonic tags on these guys. They make them quite small these days. And you can actually, in our studies out here now that track black sea bass around the islands, we can use that same technology, put those little tags on the back of abalone, and if we see the ones going south at pretty fast clip, we can see it's probably not walking. Probably hitchhiking on something. So that technology is available to do that sort of thing. That's the type of approach we would take. Yes.
What about the rickettsia infection? Is that still a problem? And on your slide, you had something about an antibiotic that
Yes.
was viable.
Yes, rickettsia is still a problem. It's mostly a problem when water temperatures get higher than about 16 degrees centigrade. We can treat animals with antibiotic. Before there were 2 methods. One, you could inject each animal, which is very tedious. The second would be to use a feed that has the antibiotic right in it. The problem is they don't really like the feed, and what we found out sort of surreptitiously is that the antibiotic is very water soluble. It's oxytetracycline. You can go to any veterinarian, or not even veterinarians, or go to a feed store. You can buy it because it's used for cattle and sheep and stuff like that when they get minor infections. It's very water soluble, and what we found out is that just having the feed in the same tank works pretty well. So now we've gone to the next step and said, well, let's make a oxytetracycline bath. And we just expose the ant, put them in the bath for a few hours, take them out, and that's enough of a dosage. They'll absorb it right through their skin. So it continues to be a problem, but there's some studies going on, and we're starting to look at, is there any resistance to the withering syndrome in the abalone? I haven't seen it to a large degree yet, but it may be possible. Yes.
You said you do commercial, does that mean you're raising them also for the?
White abalone, no. White abalone is an endangered species, and my estimate is that you will never see it in the commercial market. It's going to be such a long road to get this off the endangered species list. And we didn't get there like in one jump. We said, well, let's take all the abalone out and put it on the endangered species list. This is a fishery that went on for decades and decades. And, actually it went on for a century, quite frankly, the abalone fishery. And so it took a long time to get us to this point. It's not going to be an easy road out. You won't see it on a commercial menu in your lifetime.
So what are the ones that are raised commercially?
Red abalone, or the predominant abalone that's raised commercially in this state, there's a farm just north of Santa Barbara that's called the Cultured Abalone, and you can order abalone from them. The biggest farm in the state is called the Abalone Farm. They're by Cayucas near San Luis Obispo, and they produce probably 70% of all the abalone in the state of California, farmed abalone. There's a smattering of small abalone farms in the Santa Cruz, Monterey area. Who's been a fisherman's wharf? I mean, in Monterey. Who's walked on the wharf in Monterey? You've walked over an abalone farm. There's an abalone farm under the wharf. They have cages down below the wharf, and they raise abalone there. So red abalone, predominant abalone. So a few people raise some green abalone. Pinks really aren't raised. So red is the abalone of choice.
So in the wild, are all abalone endangered?
No, only the white is endangered. The fisheries for the other species in Southern California are closed, so you can't fish any in Southern California. If you want to fish abalone yourself, go north of San Francisco, take your wetsuit, no tanks, jump in the water, look out for sharks. Yes?
What are estimates of the extant wild population of the whites?
At one point, the estimate was as low as about 2,000, 1,500 animals. That seems to be revised upward a little bit now. There's been some work by the Southwest Fisheries Science Center looking, and they're using ROVs and things like that to survey some of the offshore banks and shoals and things like that. And they've found a few spots where there seem to be a few more abalone. So I'm not really sure what the current estimate is. It might be as much as, help me out, Gary, 5,000,
Yeah.
13, 10,000, maybe?
Probably in the thousands, not 10,000.
Yeah, probably, yeah. So we're still,
6 or 7 is probably the top number, and 2 or 3 is the lower end.
yeah, so we're still talking about a drop in the bucket as to, I mean, this is a species that went, for hundreds of miles. And now,
The estimates for the fishery are the order of 22 million animals.
Wow.
And we're down to a few thousand.
And
Think
how,
about your retirement account. You had 22 million, and now you're down to 4,000.
yeah.
and how many have you managed to raise in your hatchery?
It depends upon what size. If we're talking about larvae, we raise millions and millions. If we're talking about small juveniles, over 100,000. For the larger ones, we were up to about 15,000, but we've been battling with withering syndrome and stuff like that, so our numbers are down a bit. But we expect that in our hatchery, we would be able to produce on the order of about 10,000 animals per year at a size of 3 inches or so. And the reason we want them bigger is because when you put them out, they're highly susceptible to predation. Everybody likes to eat abalone, not only us, but lobsters, crabs, octopus, a variety of fishes will all take an abalone if they possibly can. There's no otters in our area yet, so that's not an issue right now. But everybody likes to eat an abalone if they can get one. Yes?
Is there a maximum depth that they found the white abalone at? And
What was your maximum depth, Gary, when you were doing the surveys? The deepest you found white abalone?
It was 190 feet.
Yeah. So there is sort of a lower limit in the sense that these are, again, remember they're drift kelp feeders. So you need the kelp to drift down from up above and find its way down. So if you go too deep, you're not going to get as much drift kelp as if you stay in the higher range. Yeah.
Yeah. Juggling the difference between public and private, and having worked in the whole private sector, there's a lot of big secrets on like what's the best tricks, and so were you able to take your knowledge from there over, and how public is your stuff with all of the research you're doing with the whites?
Our stuff is very public. You can have whatever you like. I've been in the abalone industry in California for a long time, and one of the biggest problems with the industry has been the secrecy. because everybody thought that they were going to find the Holy Grail first, and therefore they would be rich, and everybody else would be peons and, forget it. Didn't work. Abalone is a game of very, very small increases. You do this and you get, well, maybe half a milliliter more growth a month, and maybe you do that and you add another little bit and you do this. A lot of our stuff is published or is going to be published, but you're welcome to come in and we'll tell you everything you want to know. It's the bigger technique, rather than just this, it's not secrecy of techniques, it's how you look at the whole picture. What's your experience? If this happens, what do you do? And I can write a cookbook, but it doesn't all, you have to have the experience. So you say, well, I think we should sort of go this way at this particular juncture. And I've worked with, a number of commercial farms, and there's, a lot of people say, oh, I'm not going to pay for this, I'll do it myself. I said, you can do it. It's going to take you 5 or 6 or 7 or 10 years, but you can do it. Or I can come in and we do it in a year. So.
How do you tag them? And if you do, what are you using for tags?
We use a number of tags. I thought I had a
You
picture.
showed one with the metal tag on it.
Yeah, we have some with metal tags. Those are for the broodstock. We'll put a stainless steel wire through the respiratory pores and put a metal tag. That's very effective, lasts a long time. We can also use an epoxy glue right about here and put a little plastic number tag right on them, press it in, and that works quite well too. Those are the two best methods.
And how big are they before you put the metal in so they don't close over?
The metal ones, we tend to like abalone a little bit bigger, but it doesn't really matter. The plastic tags, we tag abalone as small as that, if we want to keep track of them. Any other question right there?
I was curious, what would be the distance between, reproducing males and females, for the white abalone?
You're probably talking on the order of 1 or 2 meters. You don't want to be much further away than that, because if you are, either the eggs get diluted or the sperm gets diluted. Again, it depends, and it's a very complex puzzle because, are you spawning when the waters are dead calm? Are you spawning when it's a big rush? If it's a big surge? Where does the sperm and egg get carried? The process is basically the females probably spawn first, and it's no secret the females decide when it's going to happen, right? And so the females will spawn the eggs. The males then can sense that chemical signature that's associated with the eggs. Then they can release their sperm and create fertilization. So you're talking a few meters, no more than that. If you're 10 meters away, you're out of the game.
And is that the same picture for the other species of abalone?
Pretty much so, yeah. And again, you have to look at where the animals are living. A lot of the abalone, for instance, if you go to areas, say, in Monterey, the sea otters in Monterey, and there's abalone in Monterey, there's red abalone. There's none, no big ones, because the sea otters get those as they move out of the cracks. But in these small cracks in the rock, you'll find little aggregates of abalone. You find maybe 4 or 5 or 6 small abalone, no bigger than that. They can spawn right in that crack. There's not a lot of water movement right there, so the eggs and sperm can meet very easily, and then this young can settle out even in the depth area sometimes. And so it all happens in a very small little space. So it depends upon the size of the animal sometimes. Yes?
If these animals are wrapping themselves up to hitch a ride someplace, it seems like they're exposing themselves more to predation, and how quickly, if they sense something coming, and how do they sense something coming? They clamp down to try to protect themselves.
Well, they're doing this activity at night, so first of all, you're avoiding a lot of predation because nobody can see it. Second thing is, what I envision is, the kelp's kind of dragging along the bottom, maybe a bigger pulled out plant or whatever. So some parts of it are dragging along the bottom. As it drags along the bottom, they grab it and jump on. Once they're on the kelp, they're very dark colored also, and they're not going to stick out. They're not like a sore thumb sticking out there. So, and they'll hold on quite tight to the kelp.
Do you think they lift themselves up waiting for something, or because they sense something there?
Both.
Okay.
Both. What we find is sometimes they're just waving there. What we did find is when we send certain items down, they can smell what's coming. For instance, if we have kelp coming down the raceway, more of them would lift up. They say, oh, okay, there's giant kelp coming. If we have a rubber tire coming down, a few of them lift up, but not so many. So they can distinguish between species, apparently, species of food. And so more of them are waving around when that kelp comes by. And all you need to do is kind of wave in front of them, they'll lift right up, and then they'll just jump right onto it.
did you test this hitchhiking thing with other?
Next problem, exactly. We were just talking about today, I was with my team, I was talking about, we're gonna get some little reds, put those next to the whites, because we've never seen the behavior of reds, and so it'd be nice to quantify whether in fact they will do it under similar conditions. Yes?
What is their average lifespan?
Lifespan, white abalone, we think on the order of 40 years or so, 30 to 50 years, somewhere in that range. Name me anything that you eat that takes longer than 3 or 4 years to get to your table. Name me one thing that you eat that takes longer than 3 or 4 years. See, and that's the thing, when we were fishing abalone, that nice abalone dinner, that was 10 years, 20 years, 40 years in the making.
Is that the same?
Good
for-
wine, no, but it only took a year, it only took 8 months to grow that wine.
Is it the same for other abalone, or is it? not the same?
Similar, but they're very long-lived. And they don't grow a little bit each year, and they don't put down annual rings, so it's very hard to age them. So they're not like other fishes where you can go in and get out the overlip and figure out how many years of growth they have. It's not that easy. And some years they will actually shrink. The shell will actually get eroded away or ground down a little bit, so it'll actually get shorter until there's better food, and then they'll grow. Maybe one more question.
How does the abalone sense its environment? It doesn't have eyes.
It does have eyes. Here's one here, and here's another one here. It has these grand cephalic tentacles, cephalic of the head. So these whip around, and these you can see you can even make them longer than this. So they're whipping around out there, sensing chemicals in their environment. They also have other additional tentacles here coming out of the respiratory pores. Again, they're sensing the environment. They're both tactile for touch and chemical as well. Then you've got all these curb feelers here. Who had curb feelers on their car? Some of you guys must have. Close enough, right? That's what these things are. These are curb feelers. There's a fancy scientific name for them, epipodal tentacles, but they're curb feelers. They can back into an area. They can feel what's back there. They want to be in a little crevice. That's their most secure little position.
So they actually have vision?
They have vision. They can see light and dark. They're not going to see clear things, but they
They
can.
would see the kelp coming down.
They can see the kelp coming
And they
down.
also sense it chemically?
Yes, both ways.
If you put water that's had kelp in it, will they rear up?
We're working on that one. We've tried it a little bit. We've got I think they may need multiple stimuli. They might need the darkness and the smell.
Well, I think you've gotten a really wonderful sense of the exploration and the discovery and the inventions that are required to do the kind of work that Tom does. Please help me thank him for coming to Great. See y'all next month.
Hey, Gabe. Very good program.